let's continue from this slide. Like we looked at the conditions of binomial distribution, and this is just basically an easy way to state all the conditions, right? So P is always probability of success. And remember, success and failure is not what the term looks like, okay? Like whatever you decide to be a success is basically what success is. So success is not always positive, failure is not always negative, and so forth. We use Q, but Q is basically 1 minus P. So when you know P, you automatically know probability of failure because there are only 2 outcomes, and then they have to add up to 100%, which is 1. Mean or expected value. So you will see sometimes written as mu of x. Okay, so if you just write mu, it's actually wrong. So you want it to write as a mu of x or expected value. Standard deviation is the same. It's basically sigma of x. Don't just write sigma. But this one, the standard deviation, only works if this condition is met. Okay, and so make sure that you check your condition. Like any problem, you always want to start by checking the conditions and continue. Because if the conditions aren't met, you can't use the formula that you think you can use. All right. Binomial PDF and CDF is a very important function from your calculator, and you should know how to get to this. But if you don't, it's the second bar, which is the distribution. When you see a problem that says exactly X number of successes, then you use binomial PDF. If they're asking up to this number, then you use binomial CDF. So sometimes you are going to see a problem like at least like 3. So then you can still use binomial CDF, but remember, at least 3 means that it's included 3, right? So another way to write is 1 minus Px smaller than 2. Because remember, binomial is discrete. There is no number between 2 and 3, okay? And binomial CDF includes the 2, okay? So, and you don't want to include 3 because it says at least. If this is greater than 3, yes, include 3 for binomial CDF, but it says at least 3, then you have to go one number less than 3 because it's discrete. Binomial CDF can be used the way it is if you use at most 3. So at most 3 will be probability as x is 3 at the greatest. So this is just a regular binomial CDF. Where you write n, the probability of success, and the number 3. Okay. Geometric distribution, it's either getting the first success, right? Because that's basically what it is. And then probably you're getting success on certain number of trial or less. Okay, that's what it is. There are only 2 types of questions, basically what it's saying. So probably the first having success on the nth trial is this formula, or you can use geometric PDF. So it has to be very specific, like you need to know which number of trial, okay? And then probably of having success on or before the nth trial is basically you're adding up all of that until that point, right? So this is the last trial, right? And then you're adding up all the way to, and you need to remember the 0, okay? And that is the most common mistake. You always forget 0. Or you can use geometric CDF, the probability of success, and the n. These 2 are actually very important because I don't think it's in the, the formula sheet. This one, mean, which is expected value, is 1 over p. So 1 over your probability of success. And the standard deviation is square root of probability of failure over probability of successes. So I don't think this is in your formula sheet. So make sure you write this somewhere in the notes. So in case they ask, although I don't think geometric distribution will be really in there, but in case they ask, please write that. Please have it somewhere so you don't get caught off guard. All right. It is very important, like I mentioned, to check condition. So I just copy pasted what I saw that I thought was very important. All right. So you must check assumption and conditions, and they're a little bit different, okay? So they are going to explain the little difference between that. Assumptions are theoretical mathematical requirements. So like independent assumption, right? We don't say independent condition, we say independent assumption. And for us to check independent assumption, we check 10% condition. So if the 10% condition is met, we assume independence. Does that make sense? And a large sample condition, assumption is also the, what's it called? Success and failure condition, right? So that's when you do NP and NQ greater than or equal to 10, right? So don't write large sample condition. It's success and failure condition. And when you meet that condition, then you can assume large sample assumption. Okay? Same thing with the 10% condition. When you meet the 10% condition, you can assume independence. All right, great. So sometimes there is no condition to test, right? If the question says it outright, then you can just say, well, the question states that the two events are independent, random independent. That's sometimes what we write so that we don't have to check random and independent conditions separately. We can just like do that together. Large sample assumption is met by success and failure condition, and success and failure condition is NP is greater than 10, NQ is greater than 10. Independent assumption is met either by having a replacement, like let's say you're drawing a card, then you do with replacement, then it's independent. Or you can do 10% condition, like if you have like a 30 people, right? Then is there more than 300 people in the population? Because you need to meet 10% condition to assume independence. All right, this one, I think we read it together in class on one day. So if you want to look into it again, you can find it on AP Central. So this is also very important, right? I know you guys think that some things are very intuitive and it's just like, oh, it's just straightforward. It says in the question, but you have to rewrite it. Like I said, if you don't write it, they don't consider it as you know it, okay? So you can't just write this and then check mark. I know some of you really like to do that. You have to show number, right? You have to show a number, and it's better if you can write it out, okay? You can write out this is a success and failure condition, and it has to meet NP is greater than 10 or equal to 10, and then you're showing as an evidence of what that number is from your question, okay? So very, very important. Don't miss points just because you got lazy in writing it down. Again, this one I wanted to show you as a quick reference and notation. This is actually from the College Board website in the AP classroom, but I don't know if you can see it or not, so I just copy pasted here. Again, do you see how they are very specific about writing that little x? Because you have to. And you know all this, okay? Expected value, how to find them. I guess I would say review these a little bit more, because when you combine the two random variables, remember the variance gets the one which gets added, not the standard deviation. Binomial, this is perfect. This is what you should have next to you when you take the test as a reference, right? You know how to find the binomial expected value or mean by doing NP and then NPQ, right? Square root of NPQ is a standard deviation. And then a standard deviation for this is square root of Q over P squared. Remember, there's a little different way to write. The other one said 1 minus P, or actually, the other one said Q over P squared, but then P squared can get out. So that's a square root of P over Q, basically. Okay. I have some questions. I'm going to do this in the next video. So I'm going to stop here for this video, and then I'll continue do the questions. So like, if you don't need to look at the questions for review, you can stop watching it. Or if you want to try it yourself first and then watch my video, that's even great. Okay, that's even better.